Hi, this is Mrs. Rodriguez, your algebra teacher. This video is a review for the Chapter 10 quiz that's coming up. What I suggest you do is when a problem comes up on the board, pause the video, try to solve the problem yourself. You get the correct answer, great, move on to the next problem. If you get to the end of the video and there were several problems that you didn't understand my explanation, you didn't get the answer correct, please call, text, email, or stop by my office hours, and I'd be happy to go over those problems with you before you take the quiz, okay? All right, let's go ahead and get started. So like I said, this is a review for the Chapter 10 quiz. These are questions from the practice quiz on page 647 of your textbook. Okay, so first thing talks about square root functions, and they contain the square root of a variable. The square root functions are a type of radical function. The expression under the radical sign is called the radicand. For a square root to be a real number, the radicand cannot be negative. Values that make the radicand negative are not included in the domain. So here we have the square root of x. Notice the domain is x has to be greater than 0 because we do not include the negative when x is negative, okay? Because you cannot take the square root of negative, all right? And then the range for the y values would be everything above 0, okay? Everything above the origin here, okay? So here it says to state the domain and the range. So here we have y is equal to the square root of x minus 3. So we know that the square root of x, we just saw that graph is like this, okay? But then it says minus 3. So this is going to move the graph, this is going to be moved down 3 units because of this minus 3. Okay, so like your kind of like your y-intercept here. So here's negative 3. So our graph is going to go like this. Okay. So when we are writing our domain, remember those are the x values. Okay. So here along the x values, they're still going to be increasing, but they started at 0, right? So x has to be greater than or equal to 0, okay? And then for the range, well, now the range, the y values, this is our y-axis, the y value started here at negative 3. So y has to be greater than or equal to negative 3, okay? All right, and then we have y is equal to the square root of x minus 1. Okay, so remember that the radicand, what's under the radical, cannot be less than 0. Okay, so if this was equal to 0, we would get x equals 1. Okay, so when x is 1, y is 0. Okay, so our graph would be starting here. Okay, and if we wanted to plug in some values here, so when x is 1, y is 0. Okay, and then I would plug in when x is 2. Okay, because 2 minus 1 is going to be 1, and the square root of 1 is 1. So when x is 2, oh, I didn't graph this correct. When x is 1, y is 0. Let me erase this here. Okay, so when x is 1, y is 0. So it'd be here. When x is 2, y is 1. Okay, I'm not going to put 3 because then it's not going to be an exact answer. So then I'm going to plug in 5. So when x is 5, we get 5 minus 1 is 4. The square root of 4 is 2. So 1, 2, 3, 4, 5. And then we go up 2. So I can get an idea of what my graph is going to be looking like. It's going to look like that. Okay, so then when I write my domain, remember those are my x values. So I look, x has to be, starts at positive 1. So x has to be greater than or equal to 1. Okay, and then my range, those are my y values. It starts at 0. So y has to be greater than or equal to 0. Okay, so when you're asked for domain and range, it might be a good idea to draw a quick sketch of your graph so you can get a visual of where your domain and range lie. Okay. All right, so product property of square root. So a radical expression contains a radical such as a square root. Recall the expression under the radical sign is called the radicand, and a radicand under a square root symbol is in simplest form if the following 3 conditions apply. Okay, first, no radicands have perfect square factors other than 1. Okay, so you're kind of almost simplifying what's underneath the radical. So no radicands contain fractions. Okay, and no radicals appear in the denominator of a fraction. Okay, so here we have the product property of squares. So we're going to use this property. If you have a times b under your radical symbol, you can break it down to the radical a times radical b. Okay, for example, if you had 4 times 9 underneath the radical, you could say that's the square root of 36, which is 6. Okay, all right. So if we have the square root, the radical 12 times radical 8, we could say, okay, well, we can break down radical 12 because it has a perfect square factor, okay? Because 4 is a perfect square, and 4 times 3 is equal to 12, okay? So that's 4 times 3, and then radical 8 also has a perfect square factor because 4 times 2 is 8. So then we know the square root of 4 is 2. And we know that the square root, again, of 4 is 2. So then we would multiply what's in front of the radical. So 2 times 2 is 4. And then multiply what's underneath the radical. Okay. 3 times 2 would be 6. So this is 4 times radical 6. Okay. All right. Then this problem here, we're taking, I would break this down to radical 72. Oops. 72 times radical x times radical y to the 5th power times radical z to the 6th. I would break down each one of these terms underneath the radical symbol and deal with each one of them individually. Okay, so 72 has a factor of 36, which is a perfect square. 36 times 2 is 72. Okay, and then radical x, we can't break that down. Okay, and then because this is x to the 1st power, we're not going to multiply to this something times the same thing and get just x. Okay, y to the 5th, we can break that down to y to the 4th times radical y to the 4th times radical y. Okay, and we are breaking it down because a y to the 4th, radical y to the 4th power, we can take the square root of that. Okay, and then radical z to the 6th power, that is equal to z to the 3rd power, and the absolute value of that, because we have this odd number, this exponent that's odd. Okay, we want the positive value, right? So if positive. You can take a negative times a negative and get it positive, but you can't take a negative times a negative times a negative and get a positive. So we want to make sure that happens. So we want the absolute value of that, because remember, absolute value is always positive. Okay, so then we're going to simplify this. This only happens when we have an odd number exponent. So square roots of 36 is 6 times the square root of 2. We're still going to multiply times square root of x. And then the square root of y to the 4th is y squared, right? Y squared times y squared is y to the 4th. And we still have to multiply by radical y. And then we're still multiplying by that absolute value of z cubed. Okay, so I would rewrite this. I multiply all my coefficients. Okay, so this would be 6 times y squared times the absolute value of z cubed. And then underneath the radical symbol, I still have 2, I still have x, and I still have y. So that would be my final simplified answer, okay? Because the only factors they have are 1. The only perfect square factor they have is 1. Okay, next one says, next section talks about quotient property of square roots. So for any real number, okay, where a is greater than 0 and b is greater than 0, the square root of ab is equal to the square root of a divided by square root of b. So in other words, if you have a fraction completely underneath the radical sign, then you take the radical of the numerator and the radical of the denominator, okay? So when you have something like this, this was 16 over 32, the radical of that whole fraction. So we can say the square root of 16 and the square root of 32. Okay, well, we know the square root of 16 is 4, and we can break down radical 32 has a factor of 16. 16 times 2 is equal to 32. And then I know the square root of 16 is 4, so that would be 4 radical 2. Now we cannot leave a radical in the denominator, okay? So in order to get rid of that square root of 2 in the denominator, what we do is we're going to multiply this by the square root of 2 over square root of 2, which is multiplying by 1, right? So then we've got 4 times the square root of 2, and then 4 times the square root of 2 times the square root of 2 is the square root of 4, which is 2. So if we simplify that, it'd be 4 times the square root of 2 over 8. Now we can simplify because 4 and 8 have a common factor of 4. So 4 goes into 4 once, and 4 goes into 8 twice. So I end up with the square root of 2 over 2, which is g. Okay? All right. Then it talks about adding and subtracting radical expressions, okay? When we do that, we have to have a common radical, okay? So, like over here, as the 4 times radical 5 plus 2 times radical 5, we can add these coefficients and then keep the radical the same, okay? So it's kind of like when you're adding fractions, you add the numerators and keep the denominators same, kind of, okay? Same idea, okay? So no, the radicand does not change, okay? All right. All right, so simplify each expression. So we have 17, this number 17, 6 times the square root of 2 plus 4 times the square root of 50. Okay, well, right now we don't have a common radical, but I can break down this square root of 50, okay? 50, radical 50 has a perfect square factor of 25, and 25 times 2 is 50. So I'm going to simplify this. I've got 6 radical 2 plus 4 times radical 25 is 5. Radical 2, so I've got 6 radical 2 plus 4 times 5, which is 20, times radical 2. Well, now I have a common radical, right? So 6 radical 2 plus 20 radical 2 would be 26 radical 2. Okay? So you have to get your radicals or your radicands to be the same, okay, in order to be able to add or subtract what's in front of the radical. All right, so next one here says square root or radical 27 can be broken down to 9 times 3. Okay, we're using 9 because it's a perfect square. And then 48 has a perfect square factor of 16. 16 times 3 is 48. Okay, and then we can simplify. The square root of 9 is 3. And then the square root of 16 is 4. So now we have like radicals here. So we would subtract 3 minus 4, which is negative 1. And then our radical stays the same. So negative 1 times square root of 3 would just be negative square root of 3. Okay. All right, next one talks about multiplying radical expressions. Okay. So it's similar to multiplying monomials. So you can multiply the two coefficients in the front, 2 times 3, and then the x times the x. Well, here you can multiply what's in front of the radical, the 2 times the 3, and then what's underneath the radical, which would be x. Okay. You can also apply the distributive property to radical expressions. All right. So this one here looks very similar to FOILing, right? We have, we're adding 2 terms here and we're adding 2 terms here, okay? So we're going to distribute here. So we've got radical 5 times radical 20, that would be radical 100 plus radical 5 times radical 3, which would be radical 15, and then radical 7 times radical 20, which would be radical 140, and then radical 7 times radical 3 would be radical 21. Then what we're going to do is try to simplify as much as possible, okay? So we've got radical 100, well that's 10. Radical 15 does not have a perfect square factor, so we leave it as radical 15. 140 does have a perfect square factor of 4. 4 times 35 is 140. And then 21 does not have a perfect square factor. Okay, so we can simplify square root of 4, which is 2. Everything else is going to come down. And we don't have any other like radicals, so we can't add anything. So that is as far as we can go on this problem. Okay. All right, so equations that contain variables in the radicand, like h equals 1 and 3400ths times radical L, are called radical equations. To solve, isolate the desired variable on one side of the equation first, then square each side of the equation to eliminate the radical. Okay. All right, so let's, we also have to account for extraneous solutions, so you always want to check your answers. Okay, so let's look at this problem here. We don't have it. The radical has already been isolated, so we don't need to do anything there. So since we don't need to isolate anything, we are ready to square both sides of this equation, okay? So you would square both sides. So when we square this radical here, it ends up eliminating that radical. And then 2x minus 7 squared, remember, is 2x minus 7 times 2x minus 7. So we've got to use that FOIL method. We've got 4x squared minus 14x minus 14x. and then negative 7 times negative 7 is positive 49. We combine our like terms, so that's negative 28x plus 49. Okay, so that would be 4x squared minus 28x plus 49. Okay, so then I'm going to add 1 to both sides here, and then I've got 2x equals 4x squared minus 28x plus 50, and then I'm going to subtract 2x from both sides here. Then I've got 0 equals 4x squared minus 30x plus 50. Okay, so now at this point, I can factor this equation. So I need the multiples of 4 and the multiples of 50 that whose multiples are going to add up to negative 30. Okay, and that happens when I multiply 2 times 10, that is 20, and 2 times 5 is 10. Okay, and if they're both negative, negative 20 plus negative 10 would be that negative 30 that I need. So my terms here are 2x and 2x, and I have negative 5 and negative 10. Okay, so then I'm going to solve each of these equations, set them equal to 0. So I've got 2x minus 5 equals 0 and 2x minus 10 equals 0. So then I would add 5 to both sides. So 2x equals 5, and I would divide by 2. So x is equal to 2.5. Here I would add 10 to both sides. So I get 2x equals 10. I would divide both sides by 2. So x is equal to 5. Now we need to check our answers. Remember it said to check for extraneous solutions, right? So I'm going to plug in 2.5 for x and see if I get a true statement here. So 2 times 2.5 minus 1, so the square root of that, equal to 2 times 2.5 minus 7. Okay, so 2 times 2.5, that would be 5 minus 1. 2 times 2.5 is 5 minus 7, so 5 minus 1 is 4. 5 minus 7 is negative 2. The square root of 4 is 2. 2 is not equal to negative 2, so that is not going to be a solution. Okay, even though when we factored, that is one of the solutions, we have to plug it in and make sure it's not an extraneous solution. So we're going to do the same thing for x equals 5. So 2 times 5 minus 1 equal to 2 times 5 minus 7. So 2 times 5 is 10 minus 1. This is 10 minus 7. 10 minus 1 is 9. 10 minus 7 is 3. The square root of 9 is 3. So 3 is equal to 3. So that x equals 5 is going to be our only solution here. Okay. All right, next problem. Now here we've got radical x plus 1, and outside the radical we've got this plus 2. So we need to get rid of that first before we go squaring anything. Okay, so this is x, radical x plus 1 is equal to 2. Okay, now we're ready to square this, square both sides. When we do that, that gets rid of that radical, so this would be x plus 1 equals 4. We would subtract 1 from both sides, so x is equal to 3. We can check our answer. 3 plus 1 plus 2 equals 4. Well, 3 plus 1 is 4. The square root of 4 is 2. And 2 plus 2 is equal to 4, so that matches. So we know we are correct here. Okay. All right, that's all I have for this review for this Chapter 10 quiz that you have coming up. If you got to this point in the video and you still had questions or you're confused about any of the problems, please call, text, email me, or stop on my office hours, and I'd be happy to help. You have a great day and good luck on your quiz.